this week, we're really introducing atoms and molecules, and we will dive into more detail next week in how molecules form and how two atoms come together and bond. Um, and so to understand that later, one idea I'm going to introduce now, and we'll talk about again, and we'll probably talk about again, is the idea of the octet rule. So we know that elements' outer electrons determine their behavior based on the number that they have. And we also know that the noble gases have 8 outer electrons, and they're inert. And once we hit that 8, we don't have a 9th outer electron. There's only 8 spots in that outer position on the element. And above that, then we would have what we call a filled outer electrons, and we would start filling further away from the nucleus after that. And so then you'd start with 1 further away, and then 2, and then 3, and then 4, and then 5, and 6, and 7, and 8, and then you'd go even further out and then fill. So there's something magic about this number 8, and with it comes stability. Elements are going to try to replicate the stability noble gases have, that inertness, that like zero need to react with anything. They're just like floating around being atoms, super happy. And so the elements, if they can have the same, we call it electronic structure, but that just means the same number of and arrangement of electrons or similar, then it will have a little bit more of that stability. So bonding is going to occur, or the formation of ions, to have an atom of an element try to have that magic 8 outer electrons. So sometimes it gains electrons or loses electrons to have that magic filled outer electrons. And sometimes it forms bonds by sharing electrons with another atom. So I wanted to introduce the octet rule and that power of that 8, and show one way that we're going to represent our element symbols, since we've been showing a few ways to do that, that demonstrate the number of valence electrons that the element has. And so we call these electron dot symbols, and they're pretty straightforward, and they're basically little puzzle pieces later on. And it's just our element symbol. So I'll do this for something different. I'll do this for phosphorus. So I would write my element symbol, and it's P for phosphorus. And then I would determine the number of valence electrons or outer electrons. And the phosphorus is right underneath the nitrogen. So that means it's going to have 5 electrons. And so I'm going to show that to somebody by just placing dots to represent an electron around the phosphorus chemical symbol. I'm going to imagine that there are 4 sides around it, though, like that it's a box. And I'm going to place the electron dot, the dots representing the electrons, around the phosphorus. And I'm going to start by putting them 1 on each side if it had 4 sides. And 4. And now I have 5 total, and I've placed 4, so I have 1 more to place. Then I would start pairing the dots to represent the electrons up. And if it had 8, I'd go through and pair them up 1 at a time. And so this symbol right here tells me that it has those 5 electrons. And whether or not it's paired or unpaired will later have importance to us when we're thinking about how things bond.